To lesson 3. This is going to be a continuation of section 4.2. Uh, and in this one, we're going to focus on the domain of our trigonometric functions and some fundamental trig identities. So, yeah, let's get into it, y'all. Okay. So, the first thing to consider, okay, is that the sine and cosine have no restrictions on their domain. That means that the domain of sine and cosine is all real numbers. Okay? Now, something that we need to pay attention to, though, if we notice here that for sine and cosine, the range goes from -1 to +1 inclusive. So although we can put any value for t into sine and cosine, the result is always going to be something between -1 and +1. Now for the tangent, okay, tangent and secant, because they are y over x and 1 over x, or they both have cosine in the denominator. That means that they are undefined at any point where x is 0. So what that means is that tangent and secant are defined for any value of t such that t is not falling into this 2n plus 1 pi over 2. And something that you need to consider is that this 2n plus 1 is the way that we indicate odd. So if you think of any integer n, if you double it and add 1, it's always going to be an odd number. So what we're saying is we exclude the odd multiples of pi over 2. Now, the last one for cotangent and cosecant, they both have y in the denominator, or sine. So they are undefined whenever y is 0. And anytime y is 0, that satisfies the equation where t is not equal to n pi for all integers n. So basically, we're just excluding all the multiples of pi. Okay, so 1 pi, 2 pi, 3 pi, 4 pi, so on and so forth, even 0 pi. Okay. All right, now let's get into our fundamental trig identities. And the first one that we are going to pay attention to is that cosecant is 1 over sine, which means that sine is 1 over cosecant. So sine and cosecant are reciprocals. Okay. Secant is the reciprocal of cosine, and cosine is the reciprocal of secant. It means that cosine and secant are reciprocals. And the last one, cotangent, is the reciprocal of tangent, or tangent is the reciprocal of cotangent. So tangent and cotangent are reciprocals. So one way that I like to kind of pay attention to this is that if you notice for sine, it goes to cosecant. And then for cosine, it goes to secant. So, just like we flip when we make a reciprocal, we're flipping the C and the S. Okay. And that's just a way that my brain likes to keep track of it. All right. So those are the reciprocal identities. These next two down here are what we call quotient identities. Okay. And quotient, so it's the ratio. So tangent is the ratio of sine to cosine. And cotangent, remember cotangent is the reciprocal of tangent, so we flip it, right? So it's the ratio of cosine to sine. All right. And then the last bit of identities that we need to pay attention to is the Pythagorean identities. Now, before we jump into the Pythagorean identities, I want to take a little detour here, okay? And I want us all to remember that when we have any right triangle with sides A, B, and C, A squared plus B squared is equal to C squared. Now, if you recall in yesterday's lecture, I mentioned that this formula of x squared plus y squared equaling 1 being the formula of the unit circle. Okay, so recall that from yesterday. So when we have our unit circle, okay, the equation of this circle centered at the origin is x squared plus y squared equals 1 because we have a radius of 1. Okay. And also recall, we talked yesterday about the sine of t being y and the cosine of t being x. So when we take a look at that, it only makes sense that if x squared plus y squared equals 1, then that leads us to sine squared plus cosine squared equals 1. Now, we can also look at manipulating these equations, and we can create that tangent squared plus 1 equals secant squared, and 1 plus cotangent squared equals cosecant squared. So what I'd like for you to do right now is take a minute and see what you can do, knowing that sine squared plus cosine squared is equal to 1, and knowing that tangent squared is going to be the same as sine squared over cosine squared. Cotangent squared is going to be the same as cosine squared over sine squared. Secant squared is 1 over cosine squared. And cosecant squared is equal to 1 over sine squared. Okay? And I would like for you to use these and manipulate this equation into the tangent and the cotangent one. All right. So what this should look like, I'm going to come off to the side here. Okay. So we're starting out with sine squared plus cosine squared is equal to 1. Well, what if I multiplied this whole thing by 1 over cosine squared? Okay, that would give you sine squared over cosine squared plus 1 is equal to 1 over cosine squared, which then gives you, so recalling that sine squared over cosine squared is going to give us tangent squared, and 1 over cosine squared is going to be secant squared. Now again, starting with the sine, sorry y'all, I hit the button to turn this off and I'm not quite done yet. So, okay, now we're going to start again with our sine squared plus cosine squared equals 1. And now this time, what if we multiply the whole thing by 1 over sine squared? Okay, well, that's going to give us 1 plus cosine squared over sine squared is equal to 1 over sine squared, which gives us 1 plus, and recall cosine over sine is cotangent squared, and 1 over sine squared, cosecant squared. And that's how we prove the other two identities. All right. Given that sine t is 15 over 17 and cosine t is 8 over 17, we want to use reciprocal and quotient identities to find tangent and cosecant. So take a minute and do that. So if sine t is 15 over 16, or I'm sorry, 15 over 17, cosecant t is 1 over sine t, which is going to be 17 over 15. And tangent t is going to be sine t over cosine t, or 15 over 17 over 8 over 17, which gives us 15 over 8.